At 10:48 p.m. local time, on a cold Alaskan night, the ground began to roar. A magnitude 7.3 earthquake struck just south of Sandpoint, violent, deep, and sudden. The shaking lasted nearly a full minute. Windows fractured, power blinked out, and across the coastal communities, phones lit up with a chilling alert, Tsunami warning. Sirens screamed into the dark. Families scrambled to higher ground. Local police went door to door. Roads jammed. The sea fell eerily silent. Then, nothing. No wall of water, no sweeping destruction, just stillness, cold wind, and questions. By dawn, the tsunami warning was canceled. No casualties, no catastrophic damage. But to geologists watching from labs across the globe, the real danger hadn't passed. It might have just begun. Because while Alaska is no stranger to earthquakes, this one struck along a particularly unstable stretch of the Alaska Aleutian Subduction Zone, a place with a brutal, unfinished history. And seismic models revealed something unnerving. This quake hadn't released pressure. It may have just shifted it. Beneath the seafloor, the Pacific Plate is still grinding under North America. And scientists fear that what we just witnessed could be the foreshock to a much larger rupture. A rupture that wouldn't just threaten Alaska, but send a tsunami hurtling toward the Pacific Rim. So what exactly happened that night, and why are geologists still holding their breath? The 7.3 quake that shook Alaska at 10:48 p.m. Alaska, daylight time, on July 2023, the earth beneath the Aleutian Trench jolted violently. A magnitude 7.3 earthquake had just struck 105 kilometers south of Sandpoint, deep beneath the Pacific. The USGS pinned its origin to a depth of 100 kilometers, not shallow enough to trigger surface ruptures, but deep enough to ripple outward across the entire region. It lasted less than a minute, but in that time, motion sensors from Kodiak to Dutch Harbor recorded intense seismic waves, sharp, snapping jolts, followed by a long, rolling sway. Within moments, the National Tsunami Warning Center issued alerts for parts of southern Alaska and the Alaska Peninsula. Tsunami sirens blared in King Cove, Cold Bay, and Sandpoint. Emergency management officials activated evacuation protocols. Local radio went into 24-hour alert mode. Police used loudspeakers to direct residents to higher ground. The ocean, for a brief moment, drew back. Everyone held their breaths. By early morning, the tsunami alert was canceled. Tide gauges showed only minor sea level changes, just centimeters in most places. There were no reported injuries, no structural collapses, and no infrastructure damage severe enough to shut down services. But even in its restraint, the quake was a warning, because this wasn't just another tremor on the fringes of Alaska's vast wilderness. It was part of a growing pattern. The same region has experienced multiple 7.0 plus quakes since 2020, including the M8.2 off Chignik in 2021, one of the largest quakes in North America in decades, each one striking within the same seismic corridor. Each one drawing more attention from geologists and risk modelers, each one deepening the question, are these isolated events or connected foreshocks? To answer that, we have to go beneath the surface, into the pressure-filled geology that makes this part of Alaska one of the most dangerous places on Earth, the sleeping beast beneath. Beneath the jagged coastlines and icy peaks of southern Alaska lies one of the most volatile geological regions on Earth, a boundary where tectonic giants collide, grind, and rupture. This is the Alaska Aleutian Subduction Zone, where the Pacific Plate relentlessly plunges beneath the North American plate at a rate of about 6 to 7 centimeters per year. It's slow, but unimaginably powerful. Over decades, strain accumulates, warping and distorting the crust until, in an instant, it snaps. That's what happened on July 2023, when a magnitude 7.3 earthquake ruptured along this boundary near Sandpoint. According to the USGS, the quake was the result of oblique reverse faulting, a mix of vertical and horizontal motion about 107 kilometers below the surface. That depth reduced the tsunami risk, but it also meant the quake shook a vast region, felt across much of Alaska's southern coast, and even into western Canada. This wasn't just a fluke. It's part of a larger seismic sequence known as an earthquake swarm, including several aftershocks above magnitude 5.0, and a magnitude 7.8 quake in the same region just 3 years earlier in 2020. The strain that caused this quake has been building for decades, possibly even centuries, in the locked zone of the subduction interface. When that zone fails, it can unleash megaquakes above magnitude 9, as seen in 1964 when a 9.2 magnitude quake, the second largest ever recorded, devastated Anchorage and reshaped the Alaskan coastline. And scientists warn that this recent quake may be more than just a tremor. It could be a foreshock, or worse, part of a stress transfer chain, setting the stage for something far bigger. Because when stress is released in one segment of a fault, it doesn't just disappear, it moves, and the next segment might be closer to failure than we think. The quakes that shaped Alaska. It was March 27, 1964. Male 5:36. The clock stopped, the ground began to move, and Alaska's world split open. Anchorage, a bustling frontier city, was shaken to its core by what would go down as the second most powerful earthquake ever recorded, a magnitude 9.2 monster centered beneath Prince William Sound. For nearly 5 minutes, the earth convulsed. Roads cracked in half. Railways twisted like ribbons. Entire neighborhoods fell into the sea. Then came the water. Tsunamis surged through coastal towns. In Seward, Valdez, and Kodiak, walls of water up to 67 meters high smashed everything in their path. 131 people died, some instantly, some minutes later when the sea swallowed them. The 1964 Alaska earthquake wasn't just devastating, it was transformative. It reshaped our understanding of geology. Before 1964, the concept of plate tectonics was still gaining traction in mainstream science. But this quake and the enormous area of slip, over 100,000 square miles, confirmed what scientists were beginning to suspect, that massive slabs of Earth's crust were colliding and diving beneath each other, triggering megathrust earthquakes. This event became the case study for subduction zone behavior. It gave birth to a new branch of seismology, and it rewrote the seismic hazard models for the entire Pacific Ring of Fire. But Alaska's violent history doesn't begin or end with 1964. In 1946, a seemingly modest magnitude 8.6 earthquake near Unimak Island triggered one of the deadliest tsunamis in U.S. history. A lighthouse 30 feet above sea level was obliterated. Entire villages were erased. The tsunami crossed the Pacific Ocean, striking Hawaii with devastating force. In Hilo, 159 people were killed. The destruction was so unexpected that it led directly to the creation of the Pacific Tsunami Warning Center. That quake didn't just change Alaska, it changed global tsunami policy. And that's just one example in a pattern stretching back centuries. Alaska has long been a stage for geologic extremes. In 1788, Russian explorers recorded violent shaking and landslides near Kodiak. In 1853, native Alutiiq oral histories describe the ocean vanishing, followed by waves that drowned entire coastal camps. In 1900, fishing crews near Sitka reported sudden sea level drops, followed by floods, likely signs of a tsunami from a quake that went unrecorded in modern systems. These weren't isolated flukes, they were symptoms of a deeper truth. Alaska is not just earthquake-prone, it's earthquake-built. The Aleutian Arc in southern Alaska form one of the most seismically active regions on Earth because the Pacific Plate is relentlessly diving beneath North America. Every quake, every jolt, every aftershock, they're all part of this long, slow battle between titanic forces miles beneath our feet. And here's the chilling part. These quakes follow patterns of stress accumulation, of quiet years, followed by violent rupture. After 1964, for decades, many believed that part of Alaska had released its stress. But recent events, like the 2020 Sandpoint 7.8, the 2021 M8.2 Chignik earthquake, and now the 2023 7.3 near Sandpoint, suggest the region isn't finished shifting. In fact, these events are migrating eastward along the plate boundary, possibly heading closer to Anchorage, which is home to over 40% of Alaska's population. Scientists are watching, mapping, modeling, but one thing is certain: the past is prologue. What Alaska has seen before, it can see again, and next time, it could be even bigger. The ground remembers. It carries scars from centuries of violence, each layer of rock a ledger of past disasters. And right now, deep beneath Alaska's crust, that ledger is filling up once more. All the signs, aftershock patterns, stress modeling, slow slip events suggest the cycle is turning again. Because in Alaska, history isn't something you read about. It's something that can wake you at 2 a.m. with walls trembling, dogs barking, and the deep rumble of a planet reshaping itself once again. But what happens when the quake doesn't strike offshore, when it strikes under a city instead? And what if it happens in the middle of winter, when temperatures drop to -20 and help can't arrive for hours? A bigger one could still be coming. At first glance, Alaska dodged a bullet. No catastrophic tsunami, no collapsed cities, just another powerful tremor in one of the most earthquake-prone places on Earth. But to seismologists, this 7.3 isn't a conclusion. It's a clue, one that might point to something much worse. That's because Alaska's southern coast sits along a volatile boundary, the Alaska-Aleutian Subduction Zone. It's a 2,500-mile-long stretch where the massive Pacific plate is diving beneath the North American plate, compressing, grinding, and storing tension over decades, or even centuries. The recent quake struck near a particularly unsettling section of that boundary, known as the Shumagon Gap, a seismic dead zone that hasn't seen a major rupture in over 80 years. Scientists have long feared it's building toward a monster quake, and this recent shaking may have transferred stress directly into that locked segment. In other words, we might be closer now than we've been in decades. If the Shumagon Gap gives way, the result could be an 8.5 plus magnitude megathrust, one capable of generating a massive tsunami and devastating coastal communities not just in Alaska, but across the entire Pacific Basin. Even more concerning, the concept of triggered seismicity, where one quake disturbs nearby faults like a row of dominoes. That means other segments closer to Anchorage, Kodiak, or even the Aleutians could suddenly destabilize in the coming weeks. And while the surface seems calm now, the USGS is watching for signs of something deeper, slow slip events or silent tremors, subtle shifts in the earth that often precede major earthquakes. They're invisible to the human eye, but can be the first signal of disaster. The science is complex, but the takeaway is simple. This 7.3 may not be the end. It might just be the start. Why this isn't just Alaska's problem. When the ground shakes in Alaska, the world doesn't just watch, it feels it. The 1964 Great Alaska Earthquake wasn't just the strongest quake in US history. It caused tsunamis that devastated towns as far as California and killed people in Oregon, Washington, and even Hawaii. That was decades ago. Today, the ripple effects could be far worse. In a hyper-connected world, Alaska's next megathrust quake could trigger tsunami alerts across the entire Pacific Rim. From Japan to Chile, Australia to British Columbia, coastal defenses would be on red alert. A powerful quake in the Shumagon Gap could generate waves traveling thousands of miles, arriving at distant shores in hours or less, shipping chaos in the North Pacific. Alaska sits at the crossroads of critical maritime routes linking North America to Asia. A tsunami or seismic sea level change could halt shipping lanes, delay global trade, and damage undersea infrastructure, including cables and oil pipelines. Oil and gas volatility. Alaska remains a major hub for U.S. oil production and export, especially through Valdez. A major quake or tsunami could disrupt refineries, pipelines, or ports, spiking energy prices on the global market within hours. It's happened before, with Hurricane Katrina and Russian pipeline attacks as proof. Atmospheric and magnetic ripple effects. Yes, powerful quakes can even impact the atmosphere. Satellite and GPS systems may pick up ionospheric disturbances caused by massive ground motion or tsunami wave fronts. That means aviation routes could be affected too, especially over the poles. Seismic triggering around the Ring of Fire. The Pacific Ring of Fire is a network of interlinked faults. When one segment ruptures, stress redistribution can subtly increase the likelihood of distant quakes, especially in Cascadia, Kamchatka, or even South America. This isn't Hollywood fear-mongering, it's a geological fact. Alaska's subduction zone is part of a global system, and when one part of that system moves violently, the rest holds its breath. Can we ever be ready? Every year, somewhere in Alaska, an earthquake hits. Most are harmless, forgotten. But seismologists track them all, watching for patterns, hoping for time, and they know something unnerving. The question isn't if a bigger one is coming, it's how much longer we have. That's why preparation is no longer a luxury, it's a countdown. Across the state, warning systems have improved. Tsunami sirens now line coastal towns. NOAA's DARTA buoys monitor open ocean pressure changes that could indicate a wave. Shake Alert, a growing seismic early warning network, can detect initial tremors and issue alerts seconds before stronger shaking arrives, just seconds. But in a quake, seconds mean survival. Yet for every step forward, a new problem emerges. In remote communities, sirens don't always reach. Some roads to higher ground are unpaved or blocked by snow much of the year. Emergency drills? Rare. Budget for retrofitting old buildings? Scarce. Experts warn that even in Anchorage, arguably Alaska's most prepared city, a direct hit could cripple power, transportation, and emergency services. And outside Anchorage, in the small towns built on mudflats and near cliff faces, a warning might arrive, but there'd be nowhere to run. Then there's public behavior. In tests, many ignore alerts altogether. Trust in the system is fragile, especially after past false alarms. And when drills aren't routine, panic often replaces action. Federal funding is stretched thin, prioritizing higher population states. Alaska, with vast land and sparse population, rarely tops the list, but its seismic risk is greater than almost anywhere in the country. Even with the best data models, the highest grade sensors, and the fastest communication networks, the question lingers. What do you do when the Earth gives you less than a minute? Seismologist Michael West once said, "We can warn, we can prepare, we can build, but we can't stop it." Because no warning system can stop the Earth when it decides to rupture. The edge of the next catastrophe. Alaska doesn't sleep. Beneath its snowcaps, beneath the silences of the wilderness and the chatter of the cities, the ground is always shifting. Sometimes imperceptibly, sometimes with fury. It's a land stitched along fractures, pinned between forces older than memory. Every mountain is a scar, every valley a record of past violence. Somewhere out there, just off the southern coast, the Pacific Plate continues its relentless dive beneath North America. Inch by inch, year by year, it stores pressure like a wound holding back a scream. And then, one day, it won't. That's how it has always worked. No matter the science, no matter the sensors, no matter how many drills or sirens or models we build, the Earth is writing its own timeline. The last megathrust quake to reshape Alaska's coast came in 1964. It killed more than 100 people, dropped entire neighborhoods by 10 feet, and sent tsunamis racing across oceans. But in geological terms, that quake wasn't long ago. It was yesterday, and tomorrow is still unwritten. In Anchorage, buildings stand taller and stronger now, wired with sensors and framed with steel. In remote villages, some homes have evacuation maps pinned to their doors. Children learn to drop, cover, and hold on before they learn algebra. But even now, even with all we know, there is no guarantee of safety, only the knowledge that something will come. It may be silent at first, a long, slow roll beneath the ocean floor. Or it may begin with a violent jolt, glass shattering, walls swaying, seconds stretching into a terror that feels eternal. And then the wave, or the fire, or the silence after. Because in Alaska, the question is never if, just when.